We are going to do a little MCA ACT prep work, reviewing some trig topics, looking at right triangle trig specifically. The first slide here just has a couple formulas and processes that often come into play when we're working with triangles. So anybody remember this formula? C squared equals A squared plus B squared. All right, Pythagorean theorem. Does it matter which side is A, B, and C? C has to be what? The hypotenuse. How do we know which one's the hypotenuse? How do we know which one's the long one if we don't know what their measurements are? Yes, it's across from the right angle. So in our first picture here, which of our sides would we label C? The 25. All right. The A and B, do they matter? Which one's which? No. All right, so I'm going to call this one A and this one B. We want to go ahead and plug them into the Pythagorean theorem. This is our way of finding a missing side. If we know two sides, we can find our third one. So A squared plus B squared, which would be 20 in this case, squared, equals 25 squared. What is 20 squared? Okay, so A squared plus 400 equals 25 squared. 25 squared. Thank you. All right, go ahead and solve for A. So A squared then would equal 225. And then how do we find A? Square root it. And always we've been talking about that plus minus in front of our square root. In this context, would we put a plus minus in there? No, we can't have a side length that's negative. So the square root of 225 is 15. So that's our missing side length. Okay. The other algebraic skill I wanted to review quick was solving a proportion. A proportion is where we have a fraction equal to a fraction. And we often have fractions when we're talking about trig. So how do we solve a proportion? Cross multiply, yes. So cross multiplying. Our technique actually is that we're multiplying both sides by the common denominator. The result is that it ends up being the cross products. So 3 times 2x plus 7 has to equal 9 times x plus 1. Distributing, we would get 6x plus 21 equals 9x plus 9. Now it's just a basic equation, variables on two sides, so we want to get everything to one side, all of our variables together. So let's subtract our 6x. And then we can subtract our 9 to get constants on the other side. 21 minus 9 is? So 12 equals 3x, which means x would have to equal 4. All right. Is that coming back to you? Yes? All right. So, right triangle trig. We have sides that we have labeled opposite, adjacent, and hypotenuse. We've talked already about the hypotenuse being that one that's opposite our right angle. Okay? But the other two sides can flip-flop depending on which angle you're working with. So if this is the angle that we're going to focus on, that symbol is theta, all right? If we're focusing on angle theta, then the opposite side is the one that's across from it. The adjacent side is the one that's right next to it that helps form the angle. But if we switch to the other angle, so if we're looking up here where x is, then our opposite and adjacent flip-flop. Okay? Do you remember the ratios for sine? Which of these sides are used for sine? Okay, in that order? Okay, so sine is going to be opposite divided by hypotenuse. cosine will be what? Which sides do we use for cosine? Adjacent divided by hypotenuse. And tangent is opposite divided by adjacent. Anybody remember a phrase that was used for that? SOHCAHTOA? Helps if I spell it correctly. So, sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. Tangent is opposite divided by adjacent. Okay. You guys did do this last year, correct? Okay. So SOHCAHTOA, we're going to use that to help us figure out our angles here. We have a triangle where two sides are labeled. Can we use that Pythagorean theorem to find our third side? Okay, so a squared plus b squared equals c squared. Which one is missing in this triangle? The hypotenuse. So c is our missing one. So setting it up, c squared equals the other two sides squared, so 6 squared plus 8 squared. So 36 plus 64 equals c squared. 36 and 64 is 100. And square rooting, we would end up with c equaling 10. So our missing side here is 10. So can we set up our ratios for sine, cosine, and tangent if we know all three sides? Okay, again, we have to focus on which angle are we looking at. In this case, we're looking at this angle. We want the sine of theta. So sine, we said, uses opposite over hypotenuse. Our opposite side would be this 6, and our hypotenuse would be the 10. So our ratio would be 6 divided by 10. And if you can reduce that, you should. So 6/10 would reduce to 3/5. Okay, cosine uses which sides? Adjacent divided by hypotenuse. So in this case, which one is the adjacent side? The 8. So adjacent 8 divided by hypotenuse 10. And that, again, we can reduce down to 4/5. Our tangent, we said, uses opposite divided by adjacent. So in this case, we would have 6 divided by 8, which reduces to 3/4. So once you know all three sides of a triangle, you can list all of your trig ratios. All right, so for this one, actually, I'm going to go back a slide, one sec here. A 6, 8, 10 triangle is one of what we call a Pythagorean triple. All right, it works in the Pythagorean formula. We have some other ones. 3, 4, 5 is a common one. 5, 12, 13, and 7, 24, 25 are some of our smaller Pythagorean triples. So if you have a triangle that has 2 of those sides, and you know your Pythagorean triples, you really can get the third side without doing a lot of work. So in this picture, we have a triangle that has sides 12 and a hypotenuse of 13. So what is the missing leg? The 5. All right, again, 5, 12, 13 is one of our Pythagorean triples. If you didn't remember that, could you do the Pythagorean theorem and find it? Yeah. All right, so you guys go ahead. I'm going to pause the video for a second. You write out the ratios for sine, cosine, and tangent of theta. All right, so what did we put down for sine of theta? Sine of theta? What did you have? 5 over 13? Okay. Cosine of theta. Somebody else. Thank you. And then tangent of theta? All right. Questions on setting up those ratios at all? All right, so this one asks us to find the values for the other two trig functions if we know that the cosine of theta is 3/7. So by telling us one of the trig definitions, that the cosine of theta is 3/7, they're really giving us two sides. Cosine uses adjacent over hypotenuse. So right away we know that for theta, adjacent side must be 3 and hypotenuse must be 7. Now we don't have a Pythagorean triple that involves a 3 and a 7. So we're going to have to go through the whole Pythagorean theorem to figure out our missing side. Which letter would we assign to our unknown side? A or B? Okay, let's call it A. Which one is B? Okay, and so C is 7. So Pythagorean theorem says A squared plus B squared, which is 3 in this case, equals C squared, which is 7. Okay. A squared plus 9 equals 49, which means A squared would have to equal a 40. Is 40 a perfect square? So when we square root this, we are either going to get a decimal number or we're going to get something like a 3 root 2, right? We're going to be exact with the 3 root 2 versus an approximated decimal, since we aren't really having to do any calculations with this. Okay, so grab your calculators. What is the square root of 40? Okay. I'm sorry, I just got done saying we didn't want to use a decimal. And then we went and used a decimal. We will be using decimals a lot today. How would we break down 40 if we kept it as an exact number? Okay, so splitting it into 4 and 10. All right, let's use the 2 root 10 for this purpose. So 2 root 10 is the value for our missing side. So what would our ratio be for sine? Which sides are we going to use for sine? Okay, opposite would be the 2 root 10. Hypotenuse would be the 7. Okay, and then for tangent, we need opposite over adjacent. So we would have 2 root 10 divided by 3. Okay. All right, now we're going to grab our calculators. If you don't have one, grab one off my desk. The very first thing we're going to do is check what mode our calculator is in, because we actually have two different ways to measure angles. We can measure them in degrees, which is what you guys are familiar with, and we can measure them in something called radians. The default on most graphing calculators is radians. So we want to make sure that we've reset it to degrees. All right, so let's go to mode. And about the 4th line down here, make sure degree is highlighted. All right, our trig functions are right here. So the first question they were asking was, what is the sine of 45 degrees? So we would just type our sine key and then 45. We've told the calculator we're entering a number in degrees, so it knows that. We don't need a degree symbol. and we can just hit enter. General rule is that trig values like this are given out to 4 decimal places. So our answer to this one would be 0.7071. All right, now we're going to find the cosine of 53 degrees. So again, using our trig keys, cosine of 53, and we should have 0.6018. Remember that if you do have to round, look at the number after where you want to chop it off. If it's 5 or higher, you're going to round up. If it's under 5, you just drop it off. All right, I'm going to pause the video. You guys go ahead and find the next 4. All right, let's check. Sine of 12 should be 0.2079. Tangent of 75 should be 3.7321. Tangent of 25 is 0.4663, and cosine of 8 is 0.9903. We doing okay with those keys? All right, so how is this different? We are now given a degree measure for an angle, but we're missing some sides. If I only know one side of my triangle, I can't use the Pythagorean theorem to find the other ones, right? We need at least 2 of them. So that's not going to work. But we can use the angle and some trig to figure out our missing side. So if 23 is the angle we're working with, how would we label the side marked X? Is that opposite, adjacent, or hypotenuse? It's opposite. Okay. How would we label the 18? I heard 2 things. What should it be? Hypotenuse. All right. It's the one opposite the right angle. And so which trig function uses an opposite and a hypotenuse? Sine. So we can say that the sine of 23 degrees should equal our opposite side x divided by our hypotenuse 18. Okay? And we really have a proportion, right? There's a 1 under that. So can we cross multiply? Or think about just multiplying the 18 over to this side? So we're going to have 18 times the sine of 23 degrees equals our unknown side. Okay, 18 times the sine of 23 degrees. So let's go back to our calculators. We want 18 sine 23. So our missing side is 7.033. All right, for our next example, take a minute and label which 2 sides you have based on this angle of 42 degrees. How would we label side X? What do we call it? It's opposite, and the 18 is hypotenuse. So same idea as the one we just did. We can say the sine of 42 degrees equals the opposite x divided by the hypotenuse 18. So again, we're going to multiply 18 to both sides. We end up with 18 times the sine of 42 degrees will get us our x value. Okay, 18 sine 42. Our missing side is 12.044. All right, I'm going to pause the recording. I want you guys to try these. Make sure you label the sides that you're given. and figure out which trig function to use. All right, let's label our sides. If we're working with this angle 77, what do I call the side labeled x? Okay, adjacent. What's the side labeled 65? Opposite. And so which trig function uses opposite and adjacent? Tangent. So we can say the tangent of 77 degrees equals opposite, which is 65, divided by adjacent, which is x. Now this one's a little different than the two we just did, because now our variable's in the denominator. We have to get that variable into the numerator for solving for it. So we actually are going to have to multiply x to both sides to get rid of it on the right, and it moves over to the left. So we have x times the tangent of 77 degrees equals 65. But tangent of 77 is just a decimal number, right? We just don't know what it is. So can we divide it over? So x is going to be 65 divided by the tangent of 77 degrees. So on our calculators, 65 divided by tangent 77. We should get a value of 15.006. All right, go ahead and try that next one. All right, checking this one. If 31 is the angle we're working with, this side here would be labeled adjacent, and the x would be our hypotenuse. Which trig function uses adjacent and hypotenuse? Cosine. So we would have to say the cosine of 31 degrees is adjacent over hypotenuse. So 21 divided by x. Right? X is not always going to be in the numerator of your fraction. So make sure you're putting them in the right order. Adjacent divided by hypotenuse. Same as the previous example, we're going to have to multiply x over to this side. And then we can divide that cosine 31 to the other side. So we need 21 divided by the cosine of 31. We should have 24.499. All right, questions on that? All right, this should be the next slide in your packet. We're going to start looking at least, what do we do if we don't know the angles? All of the trig work that we've done so far, we've had a known angle, right? They asked us, what is the sine of 45? What's the cosine of 31? We know the angle, but in this case, we don't. So if we don't know any angles, we can use what's called inverse trig. On our calculator, that's going to look like our inverse notation. Remember from our previous chapter when we talked about inverses? We had that little -1 looking exponent. So this would be the inverse sine, or we have inverse cosine, or inverse tangent. Look on your calculator. Where do you see those? Yep. We're still using those same sine, cosine, tangent keys, but now we have to hit the second key first to get these. Okay? All right, so we're going to use a calculator to evaluate the indicated angle. We want the sine of x to be 7/12. So on our calculator, we would have to say then that x is the inverse sine of 7/12. So we would type second sine to get inverse sine, and then put in the fraction 7 divided by 12, and hit enter. So the angle is a 35.7 roughly degree angle. Okay. All right, for question 2, it says that cosine of x is 3/11, which means that x is going to be the inverse cosine of 3/11. So second cosine 3/11, and we get an angle of about 74.2. Okay, I'm going to pause the recording. I want you guys to try the next two. All right, so if the tangent of x is 17/4, then x would be the inverse tan of 17/4. Should come out to be about 76.8 degrees. Okay, and the fourth one, cosine of x is 7/12, which means x is inverse cosine of 7/12, and that should be about 54.3 degrees. You okay with that? So if you're trying to find the angle measure, you're going to use an inverse trig function. If you're trying to find a side length, you're going to use regular trig functions. All right, so go ahead and set this first one up. Which sides are we missing? Or sorry, which sides are we using if we're dealing with angle x? 10 would be opposite, and 17 would be hypotenuse. Okay, so which trig function uses opposite and hypotenuse? Sine. So sine of x would be opposite over hypotenuse, 10 divided by 17. So to find x, then we are going to have to use the inverse sine of 10/17. Okay, so second sine, 10 divided by 17. And we get about 36.03. Okay, you guys do the next one. Okay, so again, focusing on angle x. Side 9 we would label adjacent, and 14 is hypotenuse. So which trig function did you use? Cosine. Cosine of x is adjacent over hypotenuse. Adjacent 9 divided by hypotenuse 14. So x would be the inverse cosine of 9/14. And what did that end up being? About 50 degrees. It's like 49.99 something. Okay, so x is about 50 degrees. Okay. All right. Our next example asks you to solve the triangle. Anybody remember what solving a triangle means? You could just read the board. What does it say? When we solve a triangle, we are finding all missing sides and angles. Everything. So a triangle should have 3 angles and 3 sides. Okay. What do we know in this first one? So we know one side is 13. We know we have an angle that's 19. And we also know we have a right angle How many degrees is your right angle? 90. And all of the angles in a triangle add up to what? 180. If we already use up 90 with a right angle, it means we have another 90 to work with for the other two. Okay, so to find this missing angle here, I would have to take 90 minus 19. What do we get? So our missing angle here is 71 degrees. So we have all the angles. Do we have enough sides that we could use Pythagorean theorem? No. So we're going to have to use some trig. If we use this angle 19, now we know the other one's 71 degrees, but what if we made a mistake with our subtraction? If we then use that 71 degree angle, we're going to get wrong answers for everything else. If we use an angle they gave us, then we have a better chance of being right. And we can solve the rest of the triangle just using angle 19. So we have a 19 degree angle. Based on that angle, 13 would be labeled adjacent, and A would be opposite, and C would be hypotenuse. Okay, so we have to use the adjacent side. If we're going to find side A, we need a trig function that's using opposite and adjacent. That would be tangent. So we can set this up. The tangent of 19 would be A divided by 13, opposite divided by adjacent. How do we solve for A? Okay, so 13 times the tangent of 19. So 13 tangent 19. So that side is 4.48. Okay. To find side C, we are going to use adjacent and now hypotenuse. That's cosine. So we would say the cosine of 19 is adjacent divided by hypotenuse, 13 divided by C. What do we have to do with the variables in the denominator? Multiply it over. Okay, so we're going to multiply C over to this. So C, I'm going to take a step back here. C times the cosine of 19 would equal 13. So to find C, we would do 13 divided by cosine 19. divided by cosine 19. We get 13.75. All right, so that's solving a triangle. So you guys go ahead and try to find all missing sides and angles on this one. All right, so given two sides, we can use Pythagorean theorem to find the other one. So 8 squared plus 14 squared equals c squared. 8 squared is 64, 14 squared is 196. What do we get when we add those? So 260 equals c squared, which means c would be the square root of 260. But the only thing you can take out of that is a 4. How many times does 4 go into 260? So we could shorten this and say it's 2 root 65 for our missing side. Comes out to be what decimal? 16.125? Okay. But we don't actually need to use that side to find our angles. We can use the two sides they gave me. So if I'm finding x, this one would be adjacent, and this one would be opposite. So which trig function uses those two? Opposite and adjacent. Tangent. So we can say that the tangent of x is opposite over adjacent, 14 divided by 8. How do we find x? We use inverse tan. So x equals the inverse tangent of 14/8. Okay, so second tan 14 divided by 8. Our angle is going to be about 60.26 degrees, 60.3 degrees. And if we know that angle, can we find angle y? Because x and y have to add up to 90 degrees. So y is going to be 90 minus 60.3. So we get y being what? Okay. All right, we're going to stop there. We'll tackle some of those word problems after break.